Okay, so good afternoon, students. Okay, so now what in the previous video we had discussed about the boiler performance. Okay, and how to compute the boiler performance. We have discussed about the different parameters, boiler's performance parameters, while we were solving the numerical about the boiler performance. Okay, so we'll continue the discussion in this respective video also, and today we'll be taking another problem. Okay, so by this problem also, by this end of this video, okay, so it what is expected is that we will be able to compute the boiler performance, okay, which is forming a part of our first module. Okay, so let's proceed to the problem. So now in this problem right now, okay, so we have a boiler which is there generating 7.5 kg of steam per kg of coal. So this is here my mass of the mass of steam that is represented in a different way here. And the steam which is generated, okay, so that is generated at a pressure of 11 bar. Okay, the steam which is there that is generated at a pressure of 11 bar, and it is generated from a feed water which is there at a temperature of 70 degrees Celsius. The boiler efficiency is provided to be 75%, and the factor of evaporation which is there, okay, so that is given as 1.15. So we'll see what is factor of evaporation and how to compute the factor of evaporation which is there. Now in this case, okay, I am given in this problem I am also given what is the specific heat of the steam which is there, that is 2.3 kilojoules per kilogram Kelvin which is there. So my specific heat of steam is also given. So this steam which is there, so whenever I am talking specific heat of steam, so then what happens, my steam which is there, that is already in my superheated condition. Okay, so only in the case of superheated phase, during the phase change, I will not be having specific heat. And in that case, I'll be having only the latent heat. So after the steam, it is converted completely. Water is completely converted into dry saturated steam. Only then the temperature of the steam keeps on increasing. So that part is there. That part will be because of the specific heat enthalpy of the steam, which is there, and that is what the value I am given here. Through these given values which are there, okay, so I have to compute the degree of superheat and the temperature of the steam generated. So now by the when in the question I am already, when I am given the specific heat of steam, so one thing that I can already understand just by reading the question is that the steam which is there, okay, so it is whatever my temperature of the steam it will be, okay, so it is already in superheated condition which is there. So when I am talking about superheated steam, there I have the terminology called degree of superheat. That means how much is the temperature, what is the degree of superheat. Okay, so very simply the degree of superheat, it is T sup minus T sat. So the for whatever pressure it is there, okay, so the T sat means my saturation temperature, and T sup is the temperature of the steam which is there. So the difference between the how much is the temperature of the steam above its saturation temperature for that particular pressure, that is known as the degree of superheat. So T sup minus T sat, that value which is there, that is called as the degree of superheat. Then after finding out, okay, so I am supposed to find out what is the temperature of the steam generated. So that means I have to find out T sup minus T sat, and then I have to find out T sup. Then I am supposed to find out the calorific value of the coal. So to find out in all the calculations, in all these values that are given, okay. So here I am given what is my steam rate, right? Here I am given my steam rate, then here I am given the feed water temperature. So when I am talking about calorific value, so the only term where calorific value comes is my efficiency. So the boiler efficiency is there. And then I am supposed to find out the equivalent evaporation. So let us first note down the parameters which are given. Okay, so firstly which is the, okay, so I am given 7.5 kg of steam per kg of coal. So when we had discussed the previous problem, okay, so there we had given it as evaporation rate. Okay, so that is also one of the performance parameters which is there. Okay, so the evaporation rate, that means the more the steam which is generated per kg of coal, the more actually I can say that the steam's efficient, the boiler's efficiency rate is higher. Okay, so the evaporation rate it is there. Okay, so denoted by MA, and that is 7.5 of kg steam per kg cool. 7.5 kg steam per kg cool. Then the pressure which is there, PS, that is given to be as 11 bar. So from the so with this pressure given, okay, so what I can do is from the steam tables, and in the pressure tables which are there, okay, so I can find out what is my saturation temperature. Then I can find out the enthalpy. I can find out the enthalpy of saturated water, and I can find out enthalpy of saturated steam. Okay, so for those I can use the pressure value here. Okay, then I am given that the feed water temperature, it is 70 degrees Celsius, which is there. Okay, so the feed water temperature, okay, so denoted by T1, that is given as 70 degrees Celsius. Then the boiler efficiency is given as 75 percentage. The boiler 75 percentage, so also I can write it as 0.75, right? Then I am given the factor of evaporation, denoted by F under subscript E, and that is given as 1.15. Then I am given specific heat of steam at constant pressure. Okay, so specific heat of steam denoted by CPS equal to 2.3 kilojoule per kilogram Kelvin. So all these parameters are given to me. Okay, so next what I can do is that from steam tables at pressure equal to 11 bar, I can find out my saturation temperature which is there. My saturation temperature, it is 184.1 degrees Celsius. Then enthalpy of saturated liquid which is there, that is 781.1 kilojoule per kilogram. Then the latent heat of vaporization, which is the latent heat of vaporization, 1998.6 kilojoule per kilogram. And then the enthalpy of steam, which is okay, the enthalpy of saturated steam, that is 2779.7 kilojoule per kilogram Kelvin. So these are values which are just taken from the steam tables. Okay, now, okay, so once I am taken this values, okay, so then the role of the steam table which is there, that is over. Now which is there, okay, so now what I can do is that I can find out the enthalpy of the feed water which is there. Okay, enthalpy of my feed water, also which we are denoting it as HF1, so that is Cp of water into T1 minus 0, the enthalpy of water, so that is CPW 4.187 multiplied by 70 minus 0, because in the question I am given that the temperature of the feed water which is there, that is 70 degrees Celsius. Enthalpy of water 70 degrees Celsius. So HF1 which is there, okay, so HF1 I am getting it as 293.09 kilojoule per kilogram. Once I am finding out the enthalpy of feed water which is there, next step that I can do, okay, so I have to find out the degree of superheat and I have to find out the temperature of the steam generator. So for both of cases which are there, the next term that I am given, okay, I can start with either the boiler efficiency or I can start with the factor of evaporation. So for that, let us first actually go through what is the expression for both of them. Okay, So the factor of evaporation. So the expression for factor of evaporation, it is H1 minus HF1 divided by 2257. And for the boiler efficiency, which is there, for the boiler efficiency, I have MA into H1 minus HF1 upon calorific value. Now, if I am looking at both these expressions which are there, okay. So here, in case of factor of evaporation, I know what is my value of factor of evaporation. Then 2257 also given. So I can find out H1 minus HF1, the difference which is there, and the H1 my HF1 which is there, that value is also given here. 293.09 we just found out. So from the expression for factor of evaporation which is there, I can find out what is the enthalpy of steam which is there. Okay, at the end, at the enthalpy of steam is exiting the boiler. Then later on, okay, after I'm finding out the enthalpy of the steam and all, after that, what I can do is that once I'm finding out the value of H1 minus HF1, then I can substitute that value in the boiler efficiency, okay, expression, and I can, because in here I know the boiler efficiency already, the evaporation rate is already given in my problem, okay, 7.5 kg per steam of steam per kg of cool, that is evaporation rate is given, the boiler efficiency is given, and from the factor of evaporation I am finding out the difference between what is the enthalpy gained by the steam in the boiler. So hence which is a I can find out the calorific value of the fuel, calorific value of the fuel which is burned. Okay, so now factor of evaporation, okay, so F denoted by Fe, that is equal to H1 minus HF1 upon 2257, and that is equal to 1.15. So implies H1 minus HF1 equal to 1.15 into 2257. So this value which is there I am getting is as 2595.55 kilojoule per kilogram. Okay, so using this value H1 minus HF1 which is there, okay, so I can find out the calorific value of the steam which is there, and after that furtherly I can also find out what is my equivalent evaporation. Okay, but right now, okay, so what I'm supposed to be finding out, I'm supposed to find out the degree of superheat and the temperature of the steam. Okay, so for that, okay, so what we'll be doing right now, let me just mark this as 1. Okay, so we'll be because we'll be requiring this later on. Okay, so let me mark this as in 1. Now here, okay, so H1 minus HF1 which is there, okay, so that I have got as 2595.55 kilojoule per kilogram, but I have already found out the value for HF1 here, right? So here I have already found out the value for HF1 which is 293.09. Okay, so implies I can say I can find out H1 equal to 2595.55 plus 293.09 kilojoule per kilogram. So the value of H1 that I will be getting, okay, so that is 2888.64 kilojoule per kilogram. So this is the enthalpy of the steam which is there. Okay, so enthalpy of steam at the boiler outlet, okay, so that I have found as 2888.64 kilojoule per kilogram. Now let me go back to my conditions here. Okay, so here which was there, okay, so here when I have found out my here when I have from the steam tables which were there for the pressure of 11 bar, the condition for dry saturated steam, it was the enthalpy of the dry saturated steam is 2779.7. Now, but the temperature of the steam that I have got at the boiler outlet, that is 2888, which is definitely larger than that. Okay, so I can, okay, so that, like we had this, I had told at the start of the question. Okay, so the temperature, the steam which is there, it is already in the superheated condition. Okay, so now from this expression which is here, okay, so here what I'll be doing from now from here, okay, so this is also denoted as H1 here. Okay, so now H1 equal to HF plus HFG plus Cp of steam into T sup minus T sat. So the expression for the enthalpy of steam which is there. Now HF plus HFG which is there. The sum of both of them, that is nothing but my Hg, the enthalpy of saturated steam which we have found out. So implies H1 equal to Hg plus Cps into T sup minus T sat. So that is equal to 2779.7 plus that specific enthalpy of steam which is that is given as 2.3 kilojoule per kilogram Kelvin plus 2.3 into T sup minus T sat. So implies H1 I had found out 2888.64, right? So implies I can write as T sup minus T sat equal to 2888.64 minus 2779.7 divided by 2.3. Okay. And this which is that I am getting it as 47.365 degrees Celsius. So now since it is in terms of temperature, it is in terms of difference which is there. So even if I am mentioning it in terms of degrees Celsius or I am mentioning it in terms of Kelvin, does not matter. But since in the question already we have given asked in terms of degrees Celsius, so we keep that same unit. Okay. So now implies my degree of superheat which is here. Okay. So I have, so for this T sup minus T sat, as I told you at the start of the question, that is my degree of superheat. Okay, so my degree of superheat which is there, okay, so that I have found out as 47.365 degrees Celsius. And along with that, okay, so from the degree of superheat which is there, I can find out the temperature of the steam. Okay, so the temperature, to find out the temperature of the steam, 40, the degree of superheat plus whatever is my saturation temperature is there, that is 184.1. Okay, so by adding both of them, I get the temperature of the steam as 231.465 degrees Celsius. Okay, so with this, my first part of my problem, so that is over. Then for the second part, now I am supposed to find out the calorific value of the cold vessel. So now for the calorific value of cold vessel, I have already found out my H1 minus HF1, right? So the F eta boiler which is there. My eta boiler which is there, that is remaining. Okay, 1 minute. Okay, so my boiler efficiency which is there. Okay, so that is MA into H1 minus HF1 divided by calorific value. So implies my calorific value which is there, that is MA into H1 minus HF1 divided by eta boiler. So which I get as MA, the value of MA which was there. Okay, so at the start of the question I am given the first line of the question itself. I am given the evaporation rate which is there, 7.5 kg steam per kg cool. Then the boiler efficiency, that is given as 75 percentage. Then the H1 minus HF1 I have found out 2595.55. Okay, so 7.5 into 2595.55 divided by the boiler efficiency which is there, that is 75 percentage, so divided by 0.75. So the calorific value of the fuel which is there, I have obtained it as 25955 0.5. Okay, and the unit it will see that will be in kilojoule per kilogram. That is the second part of the problem. Now for the third part of the problem is that I have to find out the equivalent evaporation. Now for the third part of the problem, I have to find out the equivalent evaporation. Okay, so also denoted as ME, that is equal to MA into H1 minus HF1 divided by 2257. So 7.5 multiplied by 2595.55 and divided by 2257, or implies I can get the equivalent evaporation as 8.625 kg of steam per kg coal. So with this, okay, so we have firstly what we firstly were in the question, okay, so we were given the boiler efficiency, the factor of evaporation, and the condition of the steam which is there. Okay, so I'm given the pressure at which the steam it is clean, and I'm given the evaporation rate. So with those values, okay, so firstly I took from the steam values, I have taken what my necessary values. Okay, firstly I have taken the saturation temperature, then the enthalpy of the saturated steam I have taken, then I found out enthalpy of feed water. After finding out enthalpy of feed water, I have used the expression for the factor of evaporation which is there, H1 minus HF1 divided by 2257, and I have found out the difference which was there, H1 minus HF1. So this H1 minus HF1, this term which is there, it will be useful for all the three actually parts of the question which is there. And then from that H1 minus HF1 term, I have found out what is my enthalpy of the steam at the boiler outlet. Okay, so which was my H1. After getting H1, okay, so I am finding out what is my degree of superheat which is there. So which I have obtained as 47.365 degrees Celsius, the degree of superheat, and subsequently I have found out the temperature of steam, my superheated steam which is there. Temperature of superheated steam I have found as 231.465 degrees Celsius. Okay, then so my first part of the question was over that with the in that manner. Then I found out from the expression for boiler efficiency by rearranging the terms. Okay, I am getting the calorific value of the fuel which is there, and calorific value I have obtained it as 25955.5 kilojoule per kilogram. Then I am so in the question I was also supposed to find out the equivalent evaporation. So equivalent since I know all the values, I just have to substitute them, and I have subsequently obtained my equivalent evaporation as 8.625 kilogram of steam per kilogram of coal. Okay. So with that we are concluding this problem. Okay.